Hi students, welcome back. So now we are going to talk about the next set of digital modules, and that is decoder. So in this video we are going to talk about that what is a decoder, the functionality of the decoder, the truth table, logic diagram, and how to implement a 2 to 4 decoder. So let us get started. So decoder, as the name suggests, it is going to decode something. And what does it decode? It decodes a compressed message into the original message. That means it is going to convert smaller data, that means less number of bits, into large number of bits. It is used in association with the encoders, and one of the simplest decoder is that we can convert 2 bit of incoming data into 4 different messages. So decoder will have 2 bit as input and 4 bits as the output. This is what 2 to 4 represent. That means 2 input bits to 4 output bits. Based on the input bit combination, only one of the output bit will be 1, other 3 will be 0. This is different from demultiplexer. In demultiplexer we had a very similar approach. Depending on the value of select line, one of the output will be X, others will be 0. But here that one output will be 1. In demultiplexer that value could also be 0. So here we have a difference. The remaining bits will be 0. So this is one major difference between decoder and demultiplexer. So decoder is mainly used in the communication channels. So how do we use that? Here is a person who want to communicate with 4 different person. That means ideally he will need 4 channels. That means 4 wires or 4 lines. But then we say next day you can communicate with millions. So can we have millions of wires? Well, then we say we will suggest you something better. Use a decoder. Use less number of lines and they will decide where do you want to connect. And this is exactly what we do in the telephones. Our numbers are those select lines for the decoder, and based on the number we are connected to one of the user. Nowadays we are mostly using the mobile services where the channels are wireless, they are invisible. But when the telephone started, the lines were all wired, physical wires. And if you remember, there used to be a message that all lines of this route are busy. What does that mean? That means using these limited lines, we are trying to connect thousands of users of one city with thousands of users of other city. But there are only 4 or 5 lines. And if those 5 connections are made, then the 6th person cannot connect. And that is why we got the message that all lines are busy. But it is very efficient way of communicating, because at one time all 1000 users are not communicating. And this is how the decoder made the telephone communication possible. Now let us talk about the design aspect. It is very simple. I have 2 inputs, A and B. I can call them D0, D1, anything. And I have 4 outputs, Y0, 1, 2, 3. The logic is simple. Based on the combination of inputs 0, 0, 0, 1, 1, 0, 1, 1, out of Y0, 1, 2, 3, only one will be 1, the remaining will be 0. So for 0, 0, Y0 is 1. For 0, 1, Y1, 1, 0, Y2, and 1, 1, Y3. We can design our decoder in exactly opposite way also. That means the assigned output will be 0 and all others will be 1. The bubbles at the output terminal of our block diagram represent that the output have been inverted, they have been complemented. So now we know about the design part. Let us design it in Vivado. So here we have the module declaration. Inputs are D0 and D1. You can take A and B, that is all fine. The outputs are Y0, Y1, Y2 and Y3. So now let us write the code. The code is simple, that Y0 is basically AND of D0 bar and D1 bar. D1 is on the higher side, D0 is on the lower side in terms of bits. So we say assign Y0 equal to complement of D1 and with complement of D0. So this is our first assignment. Now we can copy this assignment and we can assign the other three. So here we have Y1, Y2 and Y3. 0, 0 is the first case, 0, 1, then 1, 0 and 1, 1. By removing the complement, we are making those bits as 1. Now we save it and let us check the schematic for the same. So here we have the schematic and you can see for Y0, I have D1 0 and D0 as 0 and remaining connections also can be verified. Let us check the functionality using the simulation waveforms as well. So now we can see when it is 0 0, Y0 is 1. For 0 1, Y1. For 1 0, it is Y2 and for 1 1, it is Y3 and it will repeat in the same way. So this is how the decoder works. So students, now we have learned about 2 to 4 decoder. Let us implement a 3 to 8 decoder also using 2 to 4 decoder. We'll do that in our next video. Keep learning. Thank you.